This is the 2022 AMC 10B, problem number 16, and 12B, problem number 13. The diagram below shows a rectangle with side lengths 4 and 8, and a square with side length 5. Three vertices of the square lie on three different sides of the rectangle as shown. What is the area of the region inside both the square and the rectangle? Okay, so it shows us this area that we're looking for right on the inside, this shaded area. So the question is, well, getting the two of these vertices of this square to lie on these two sides isn't that hard. There's a lot of different ways to position it. But of course, the third stipulation is what really fixes the square in place, because it has to be on this side, right? Like, for example, if we were to position the square like maybe like this instead, right? Then its corner would like not end up on the side, right? So this corner is what we have to use. And if you'll notice, the fact that the side length of the rectangle being 8, that does not contribute to the answer to the problem at all. That's just some erroneous information, right? Because this part is not even a part of the problem, right? So if we look at just this diagram, we'll quickly realize that, well, if we carry over the side lengths of the square of 5, right? And then we realize, well, this is a rectangle, right? This side length is 4. Why don't we move it to the other side? And we see, oh, see, this vertice comes into play here because we have 5 and we have 4, and it makes a right triangle. So we know that this length here is 3, right? So now, basically, what that tells us is that because this proportion is the same, right? 4, 3, 5, and these two triangles, right? These two angles are complementary because they add up to 90 degrees because of this 90-degree angle here, right? And that basically means that because of the right angles here as well, they're similar. And because of the equal sides here, right, by what is basically AAS congruence, the two triangles are congruent. So this side and this side are also 4 and 3. And this side is of length 1. And yeah, as you can see, the side length of 8 we had before, right? The side length of 8 is useless because we have an extra 1 at the end here, but that doesn't contribute anything to the solution. And now we just want the area of the region inside both the square and the rectangle. So the question is, how do we find that area? Well, the only length that we need now is this length right here, because then we have a trapezoid with 2 bases and the height. So how do we find that length? Well, once again, by the same type of argument we used before, these two triangles right there, those are similar with the ratio of this side to this side, right? The ratio of this side marked 1 and the side we're looking for is in a ratio of 4 to 5. So 4 to 5, which makes this side length here 5/4, which makes the total area of that region 5 plus 5/4 over 2 times 5, which gives us 25 over 8 times 5, 125 over 8. If we simplify that, 8 goes into 125 15 times with the remainder 5, 15 and 5/8, and our answer is D.